Hello and welcome in today's lecture. In the previous lecture we saw that how we could configure Cisco switches as IPv4 DHCP servers and also DHCP relay agents. And in this lecture we are going to configure these switches as IPv6 DHCP servers and also DHCP relay agents. Are you ready? Let's start our today's mission. As a CCNP switch candidates, I'm sure all of you knows the basics of IPv6. Therefore, in this lecture, I don't want to dig in these basics. So, if you forgot about these things, please refer to your CCNA course and review IPv6 related basics such as the type of addresses, how to notate these type of addresses and the types of the addresses which are available in IPv6 and all the basics which are available in CCNA curriculum. In this lecture, we just want to make a quick review about DHCP related for IPv6. In IPv6, just like the IPv4, we have two methods for IP assignments: static assignments and dynamic assignments. Static assignments could be very awful in IPv6 because you as network administrators have to assign 128 bits for each client manually. And it is very hard work. So in IPv6 networks, using DHCP servers are crucial. In Cisco devices, we could configure three types of DHCP servers for IPv6: Stateless, DHCP version 6, and Light DHCP version 6. In Stateless auto configuration, you could configure only IP prefix length, which is equal to subnet mask in IPv6 terminology, and default router or default gateway. Stateless configuration is very easy. I could say that you don't need any special configuration for DHCP. You just need to configure an IPv6 on your interface and enable IPv6 unicast routing. Only these two configurations. And after that, with the help of a protocol which is called NDP or Neighbor Discovery Protocol, clients could ask the routers by messages which are called router solicitations and ask them about the prefix and the prefix length and the IP of the router as the default gateway, and the routers answer them by messages which are called router advertisement and give them these information to them. In DHCPv6, just like IPv4, we configure many options for clients, and clients ask the DHCP and DHCP will answer them with those options. You could configure DNS server, domain name, and many other options. The Light DHCP has the simplicity of the stateless configuration and the flexibility of DHCPv6. I will show you this feature in the configuration. So we have three types of dynamic assignment in IPv6: stateless, which could only assign IP prefix default gateway; DHCPv6, which is just like the IPv4 DHCP server; and Light DHCPv6, which has the simplicity of the stateless and the flexibility of DHCPv6. In three of these methods, you assign the 64 bits, and the remaining 64 bits are created by the clients. You know that these 64 bits must be unique for each client, and client uses their MAC address to meet this uniqueness. But MAC addresses are 48 bits. What about the remaining 16 bits? In IPv6, we use FFFE in the middle of two parts of 24 bits of MAC address. I mean, we put the 21st two bits of MAC address, which is called OUI or Organizationally Unique Identifier, at the beginning of the address, and in the middle we have FFFE, and at last we put other 24 bits, and so it will become 64 bits. By this mechanism, we could be sure about the uniqueness of these 64 bits. But to be sure about the uniqueness of the IP address, clients again check for duplication before assigning this part to themselves and ensure us that their IP addresses will be unique in the network. Since IPv6 related topics for CCNP courses mostly cover in CCNP route course, and in CCNP Switch only, the Cisco wants to emphasize about configuring DHCP server. It does not put many curriculum for IPv6, just how to configure a DHCP server for IPv6. Now we made a quick review on IPv6 DHCP server and we're ready to start our configuration. Let's go. Okay, this is our scenario. We have 4 switches, switch 1, switch 2, switch 3 and switch 4, and a router, router 1. We want to configure switch 1 as a stateless DHCP server. Only assigns the IP address, the prefix length and the default gateway, which is the IP address of interface VLAN 1 of switch 1. We want to configure switch 2 as a DHCP v6 server. And we want to configure 2 pools on this switch, one for PC2 and one for PC4. And we want to configure light DHCP on switch 3. And we want to configure switch 4 as the DHCP relay agent for PC4 and ask the related IP address from switch 2. The IP address ranges are this: 2001, CE9, A, B, C, and D for our 4 networks. And router 1 is responsible for routing between our clients. We have lots of things to do, so I don't waste the time and start our configuration. We do it from switch 1 and verify our configurations step by step. For configuring a stateless DHCP server, you don't need anything. You just need to enable IPv6 routing on your devices and assign the related IP address to your interfaces. Everything is done by messages, which are the parts of Neighbor Discovery Protocol or NDP. And these messages are called router advertisement and router solicitation. You know these from CCNA. We go to switch 1 and configure interface VLAN 1, IPv6 address 2001 CE9 A, and I assign the number 1 IP address with /64 and no shutdown. I want to show you that before you enable IPv6 unicast routing on your devices, your stateless DHCP server won't work. So I go to PC1, and in GNS3 for VPCs, if you want to ask your PCs to get their IP addresses from DHCP servers, if your DHCP servers are IPv4 ones, as we have them in the previous lecture, you have to issue IP DHCP command. And if your DHCP servers are IPv6 ones, you have to issue IP auto command. And now you see that now router answered IPv6 router solicitations. Router solicitations or RS messages are a type of asking for router advertisement, and the PC sends these messages but nobody answers him because we don't enable this on our device. So we go to switch 1 and issue the command IPv6 unicast routing. And now I expect that when I issue IP auto command, the PC gets this IP address. You see that this is the first 64 bits and this is our PC's MAC address, and these are FFFE and these are the next 24 bits. So the PC takes its IP address from a device without any special configuration for DHCP. And now if I issue show IPv6, you see that the client has 2. This is link local address and this is your global IP address. The only thing is different because you see that this is 0 but this is 2. This is a bit which is called UL bit, universal or local bit, and if your DHCP server is like this, this will change to 1, which is defined by IPv6 laws. You see that the MAC address is 0050 but here we have 2050. This 2 is the consequence of changing the universal local bit to 1. Therefore, it changes to 2. It's the 7th bit of the first byte. So PC1 now has an IPv6 address, and hopefully I think we could ping our switch 1 IP address. You see that? They are connected to each other. Now we go to switch 2 for configuring a complete DHCP IPv6 server. Like the stateless configuration, first we have to enable IPv6 unicast routing as the first step. Now I go to interface VLAN 1 and assign the IP address of IPv6, of course, address 2001 CE 9 B1/64. Now I want to configure DHCP pools. IPv6 DHCP pool, like IPv4, the only keyword is changed. In IPv4 we had IP DHCP pool and the pool name, and in IPv6 we have IPv6 DHCP pool and pool name, and I name it pool 1. And you see that config-DHCP changes to config-DHCP v6. Instead of network command, we have address prefix command. Instead of network, we say that this is address prefix. And I put the prefix for our networks, /64. This is our network prefix. For example, I assign a DNS server 2001 CE9 B, for example, 10. This is our DNS server. And our domain name is, for example, GNS3.com. We couldn't check them because VPCs are not showing us the domain names, but I just want to show you that how you could configure these types of configurations. And you have other options, as you could see. Now this is our first step. We just configure this, and now we have to do one thing more. We have to go to interface VLAN 1, interface VLAN 1, IPv6 DHCP server, and our pool name, which was pool 1. And we say that for interface VLAN 1 you have to use this pool. And after that we have to take this interface from shutdown mode, and now this is exited from shutdown now and change the state to up. Now in PC2 I expect that this PC could take its IP address from our DHCP server. Unfortunately, in VPCs in GNS3 for IPv6 we couldn't see the DNS server configurations. For IPv4 it's possible with show IP all command. You see that if you configure DNS servers it will show you that, but for IPv6 at least I don't know how, but if we issue the same command for IPv6 there is no DNS column, so we couldn't differentiate between DHCP server and stateless, because in stateless you could not assign the DNS server to your PCs, but in here we could have them. We could test it with configuring a DNS server and see that the PC will ask the DNS server for pings, for example. I could check it in this way, I think so, but it's not in our topic. You could do it yourself and see that the differences between DHCP assignments and stateless assignment, but because you may say that this is not different between PC1 and PC2, both of them has the same type. Yes, this is correct, but the difference between stateless and IPv6 DHCP server is that you could configure other options as well in IPv6, which are not possible in stateless. Now I go to switch 2 and configure the next pool for PC4, IPv6 DHCP pool 2, pool, and then the name pool 2, and then address prefix 2001 CE9 and D/64. I don't configure other options because they are not usable for our scenario. Now I go to switch 3 and I want to configure a light DHCP server. A light DHCP server is different with DHCP configuration only in assignment of address prefix. You could configure a light DHCP without assigning address prefix. You may say that, it's just like the stateless configuration. Yes, it's just like the stateless configuration. You don't need to configure address prefix. The simplicity is just like the stateless. But in light DHCP, you could have those other options that are available in IPv6 DHCP server. I mean, we have the options and we have the simplicity of stateless. You don't need to configure address prefix here, but you could configure options. And it is the difference of light DHCP and stateless configuration. So we go to interface VLAN 1. First, let's assign an IPv6 address in the range CE9C and /1/64 and no shutdown, and then configure our DHCP pool here just like DHCP v6 pool, IPv6 DHCP pool 1, and we don't need the address prefix. We could configure, for example, DNS server 2001 CE9 C10 and domain name as GNS3.com. Now for assigning this DHCP server to that interface VLAN, we need another configuration. So we go to interface VLAN 1 like IPv6 DHCP server, and we say that IPv6 DHCP server is the pool 1, and we need a magic command here to say that although it is just like a stateless DHCP server, but clients, you could have other options. I mean that although we did not configure address prefix, clients, you could have options. And it's the difference between me and the stateless DHCP server. The magic command is IPv6 ND, which is for neighbor discovery, and other config flag. And with this command, clients understands that they could have other options besides the IP prefix and the default router in their configurations from the DHCP server. Now I go to PC3 and say that IP auto. I expect that PC3 could not get the IP address because we did not enable IPv6 routing in switch 3, and it is IPv6 unicast routing. Now PC3 also could have IP address. Now we go to switch 4 and configure DHCP relay agent. Just like IPv4, configuring IPv6 relay agent is just one command. So we go to configuration, IPv6 unicast routing, interface VLAN 1, assign the IP address of IPv6 address 2001 CE9, and for this is D and 1/64 and no shutdown. And the magic command is IPv6 DHCP relay destination and the IP address of your DHCP server, which is B1 for our scenarios. Switch 2's IP address is 2001 CE9 B1. Let's check it first with command show IPv6 interface brief You see that 2001 CE9B1, and we configured this. But before that, these devices should see each other through router 1. So we need to configure router 1. I do this. First, let's enable IPv6 unicast routing, and then we go to Ethernet 0/0, assign an IPv6 address, IPv6 address 2001 CE9 for this network is A, and 2/64, and no shutdown. Now it must ping 2001 CE9 and A1, and they're connected. Now I go to interface Ethernet 0/1 and assign IPv6 address 2001 CE9, and for this network it's B and 2/64, and no shutdown, and ping 2001 CE9 B1, sorry, CE9, I put 8 here, and they're connected. And then I go to interface ET0/2 and assign the IPv6 address 2001 CE9 and C2/64, and no shutdown, and ping 2001 CE9 C1, they are connected. And finally interface ET0/3 IPv6 address 2001 CE9 and D2/64, and no shutdown. Check our connectivity, ping 2001 CE9 D1, and they're connected. The remaining command is only one default route for IPv6, and IPv6 route /0. The next hop is 2001 CE9 A2 for this. Let me copy this command. For switch 2, we go to global configuration mode, and here this is B, and here this is C, and here this is D. Now I expect that switch 4 could ping the DHCP server, which must relay it 2001 CE9 and B1, and you see that they are connected. Switch 4 is connected to switch 2, so we expect that switch 4 could relay the DHCP requests from client to switch 2. Let's check it. IP auto command, you see that PC gets the IP address 2001 CE9D. It gets the D range because the request sends from this, which has the IP address in the range of D. Now I expect that all PCs could ping each other because all of them have IP addresses, default gateways, and the routing is complete in router 1 because all of the networks are directly connected to router 1. So in PC1 I could ping 2001 CE9 and B1, which is switch 2 IP address. You could take PC2's IP address from here and check your configuration between your two PCs. I got it from here, and say that ping, and you see that they are connected as well, and the same is true for other networks as well. I expect that I could see C and D. You see that all of them are connected to each other and our map is completely connected. Debugging commands are the same, only IPv6 keyword is replaced. I mean, for example, instead of show IP DHCP pool, we have here show IPv6 DHCP pool. And instead of show IP DHCP binding, we have show IPv6 DHCP binding. And instead of clear IP DHCP binding star or your IP address, we have here clear IPv6, clear IPv6 DHCP binding, and you have the star option or your special IP address. I think we are done our today's mission, and our today's mission is complete, and now we are ready to wrap up our today's lecture. Okay, in today's lecture we configured 3 types of IPv6 DHCP servers on Cisco switches. We configured switch 1 as a stateless DHCP server, switch 2 as a DHCP v6 server, and switch 3 as a light DHCP server, and switch 4 as a DHCP relay agent for PC4. We configure all of these, and then we verify IP assignment process, and we saw that all of PCs takes the related IP addresses from the DHCP servers, and after configure routing on our router, we test connectivity between our PCs, and we see that all of our PCs are connected because they have the IP address, they have the prefix length, and they have the default router. And finally, we saw some troubleshooting commands, and you see that all of the troubleshooting commands between IPv4 and IPv6 are the same. Only IPv6 command is replaces IP. For example, instead of show IP DHCP pool, we have show IPv6 DHCP pool. Instead of show IP DHCP binding, we have show IPv6 DHCP binding, and etc. I hope this lecture helps you to improve your knowledge, and see you in the next lectures.